Hello students, my name is G. Nikita. I'm Pharmacy Assistant Professor in Department of the Pharmaceutical Chemistry. I will deal the Medicinal Chemistry 2 subject for B Pharmacy 3rd years first semester. So today we are going to discuss about anti-hyperlipidemic agent. It is the third unit. The topic name is anti-hyperlipidemic agents. So, in this we will discuss the introduction, classification, and the drugs used in the anti-hyperlipidemic agent, mechanism of action, structural activity relationship, structure, adverse drug reactions, and uses. So, before discussing about what is the anti-hyperlipidemic drugs, let's discuss what are the lipids and what is its function in our body and what are its uses and how it will cause effect to our body. So, lipids generally, these are the fat substances. So, lipids are fat substances which are produced in our body. So, naturally, some of the fat are produced in our body, that is the lipids. So, basically our body requires some amount of the fat and it is produced by our body and it is insoluble in the water, and also although the body synthesizes the required amount of the lipids, but also we are taking the lipids through the food. So if we are taking the lipids through the food is very harmful to us. So the plasma lipids, because it is water insoluble and it needs to transport it through the carrier known as lipoproteins. So an increase in the lipid, particularly cholesterol, is involved in the damage of the heart. So here nothing but lipid is a fatty substance that is naturally produced in our body. So what are the fat amount is required for our body? It is synthesized by our body itself. So in the food also there will be the fats. If you take the fatty food substances, it is very harmful to us. So if the cholesterol level is going on increasing in our body, it will be damage to our heart. It may cause us the heart attack or a stroke. So let's see what are the types of the lipoproteins. That is 4 types. So first one is high density lipoproteins, second one low density lipoprotein, and third one intermediate density lipoprotein, and fourth one very low density lipoprotein. So let's see what is the high density lipoprotein. So the high density lipoprotein is very good cholesterol and it will helpful for the coronary artery disease and easily removed from the body. This low density, intermediate and very low density will cause harmful to our body and it may cause the heart problems. Next classification. So and this first one is HMG-CoA reductase inhibitor. So in this first drug is lovastatin. If you see the structure here, this is the naphthalene. So 6 membered rings are there. Naphthalene in the third and the 7th position, methyl groups are attached to methyl groups, and here in the 8th position, 2 carbon atoms are there, means ethyl. So this ethyl is attached to the oxane structure. See here, 6 membered ring with oxygen atom is oxane. Here in the 4th position, hydroxy group is there. In the 6th position, oxygen group. And here for the naphthalene, in the first position, 1, 2, 3, 4. 4 carbon atoms are there. So, and in the second, that is the butyl. In the second position, methyl is there. So, here 2-methyl benzoate. See here, this is the naphthalene. In third and the 7th position, methyl groups are attached. And here in the first position, 2-methyl benzoate, and here ethyl, and this is the oxane, 2,4-hydroxy, In sixth position, oxygen group is there. Next one, simvastatin. Here, this is the naphthalene structure. See here, this is the naphthalene. In third and the seventh position, methyl groups are attached. Here, in the eighth position, the two carbon atoms are there, means ethyl, and this ethyl is attached to the oxane. And in the fourth position, hydroxy group, and sixth position, oxygen group is there. Again, in the first position of the naphthalene, here benzoate, four carbon atoms with one oxygen, so it is benzoate. In the second position, two methyl groups are there. See here, two methyl groups are there. So the difference between the lovastatin and simvastatin structure is only simple. The difference is that is in the second position of the benzoate, for the simvastatin, two methyl groups are attached, but in the lovastatin, only one methyl group is attached. That is only the difference between the lovastatin and simvastatin structure. See here, in second position, two methyl, dimethyl groups are there. Here in the second position, only one methyl group is there. Remaining structure is same. Next, metastatin. If you see the here, this is the six-membered ring, that is phenyl. In the para position, the three fluorine atoms are attached. And here in the ortho position, sorry, in the meta position, the cyanide group is attached. And here this is a five-membered ring structure. So this name is So this is a diazole structure. For this dia means sulfur, azole means nitrogen. How many are there? Two. So it is diazole. Here for oxygen group is attached and two methyl groups are attached. Again here six-membered ring. For the six-membered ring, fluorine is attached, and here the methoxy group is attached. See here CH3O. So methoxy group, for this methoxy group, the methyl amino group is attached. Next, provastatin. If you see the structure of the provastatin, so if you see the structure of the provastatin, this is the naphthalene. See here, this is the structure of the naphthalene. In the sixth position, hydroxy group is there. In third position, methyl group. And again in the here in the eighth position, 1, 2, 3, 4. Four carbon atoms are there. So it is butane. In the second position, methyl is there. So it is 2-methyl butanoil. And again here the ethyl group is there. See here how many carbon atoms are there? Two carbon atoms. So it is ethyl. In the fifth position, 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms are there. So it is heptane and it is COOH is there. So it is named as heptanoic acid. For this heptanoic acid, in the third and the fifth position, two hydroxyl groups are there. See here, two hydroxyl groups are there. So this is the naphthalene structure. In the sixth position, hydroxyl group. Second position, methyl. And in the eighth position, butanoic. Butanoil. And this is the oxy. 2-methyl butanoil oxy. And here 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms. So heptanoic acid. In third and the fifth position, two hydroxyl groups are there. Next, atorvastatin. So this is the structure. If you see the structure of the atorvastatin here, 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms are there. It is heptanoic acid. In the third and the fifth position, two hydroxyl groups are there. In third and the fifth position. So at the seventh position of the heptanoic acid, this pyrrole structure is attached. See here at the seventh position, the pyrrole structure is attached. For this pyrrole, at the fifth position, propane is attached. 1, 2, 3. 3 carbon atoms is propyl. And here in the second position, 4 fluorophenyl structure is attached. So for the phenyl structure, at the fourth position, fluorine atom is attached. So it is 4 fluorophenyl. In the third position, phenyl group is attached. Here in the fourth position, phenyl carbonyl is attached. See here, 1, 2, 3, 4, 5, 6 and 7. 7 carbon atoms. It is a heptanoic acid. In third and the fifth position, 2 hydroxyl groups are attached. If you see here in the seventh position, the pyrrole means 5-membered ring with 1 nitrogen atom. So it is named as the pyrrole. In the second position, 4 fluorophenyl. In the third position, phenyl. And in the fourth position, phenyl carbonyl group is attached. In the fifth position, the propyl group is attached. Next, rosuvastatin. So this is the structure of the rosuvastatin. If you see the structure here, 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms. It is heptanoic acid. In third and the fifth position, 2 hydroxyl groups are there. See here in third and the fifth position, the hydroxyl groups are there. In the sixth position, 1, 2, 3. 3 carbon atoms means propyl. In the fourth position, the 4 fluorophenyl is attached to the with piperidine. So it is attached to the pyridine structure. See here, 6-membered ring with 2 nitrogen is pyridine. In the second position, the methyl amino and sulfonomethyl is attached. See here, 1, 2, 3, 4, 5, 6, 7. So it is a heptanoic acid. In third and fifth position, 2 hydroxyl groups are attached. At the seventh position, this pyridine structure is attached. See here in the seventh position, the pyridine structure is attached. So to this pyridine, in the sixth position, the propane group is attached. In the second position, methyl and sulfonamido methyl is attached. In the fourth position, 4 fluorophenyl is attached. Next one is fibric acid derivatives. So in this first drug is chlorfibrate. So this is the structure of the chlorfibrate. If you see here, this is a 6-membered ring. At the means that is phenyl. At the fourth position, chlorine atom is attached. Here in the first position, 1, 2, 3. 3 carbon atoms means propane. For this propane, in the second position, the methyl is attached. So 2 methyl propionate. Here 2 carbon atoms are there. So it is ethyl. See here, phenyl. In fourth position, chlorine atom. Here, this is propionate. 2 methyl propionate and ethyl group is attached. Next one, gem hydroxyl. Next name is gem hydroxyl. If you see the structure here, 1, 2, 3, 4, 5. 5 carbon atoms, pentane. Here carboxylic acid is there. So it is pentoic acid. In the second position, 2 methyl groups are there. In the fifth position of the pentoic acid, the phenyl ring is there. Phenyl ring in second and fifth position, 2 methyl groups are there. Here one of the oxygen group is there. So it is 2, 5. dimethyl group is attached at the fifth position of pentoic acid. See here 1, 2, 3, 4 and 5. So it is pentoic acid in second position 2 methyl groups. In the fifth position of the pentoic acid 2, 5 dimethyl structure is attached. Next drug name is benzafibrate. So this is the structure. If you see in the structure here 1, 2 and 3. 3 carbon atoms with carboxylic acid group. So it is name is propionic acid. For this propionic acid in the second position methyl group is there. So in the second position of the propionic acid, this phenoxy structure is there. See here, phenyl with one oxygen group. So it is phenoxy. In the fourth position, 1, 2. 2 carbon atoms are there. Ethyl, and here this is a formamido. And for this formamido, the 4-chlorophenyl structure is attached. See here 1, 2, 3. Propionic acid in the second position methyl. Here in the second position phenoxy group is attached. And here ethyl, formamido and 4-chlorophenyl. So this is the structure of the benzafibrate. Next Phenofinrate. If you see the structure here, this is the 4-chlorobenzoate. See here in the fourth position, chlorine atom is there for the benzoate structure. So 4-chlorobenzoate. 4-chlorobenzoyl. For this 4-chlorobenzoyl here, phenoxy structure is attached. See here, this is a phenoxy, and here 1, 2, 3. 3 carbon atoms are there. So it is propionate. In the second position, methyl group is attached. Here 1, 2, 3. 3 carbon atoms means propane. See here, at the fourth position, chlorine atom is attached to the benzoyl. This is the structure of the benzoyl, and here for this benzoyl phenoxy is attached, and for the phenoxy here 1, 2, 3. 3 carbon atoms with carboxylic acid groups. So it is propionic acid, and here 1, 2, 3. 3 carbon atoms is named as propane. Next, cyprofibrate. Cyprofibrate structure. We see here the cyprofibrate structure here. 1, 2, 3. 3 carbon atoms with carboxylic group is the propionic acid. In the second position, the methyl group is attached. See here in the second position, methyl. So 2-methyl propionic acid. In the second position of the propionic acid, the phenoxy is attached. See here, phenoxy. In the fourth position, cyclopropane. So the 3 carbon atoms are there. It is in the cyclic form. So it is cyclopropane. For the cyclopropane in the second position, 2 chlorine atoms are attached. See here 1, 2, 3. Propionic acid. In second position, methyl group and phenoxy group. In fourth position, cyclopropane. 2 chlorine atoms are attached at the second position. Next, bile acid plus bile acid derivatives. So if you see, the first drug is cholestyramine, next one is cholesterol. First, see the structure of the cholestyramine. So if you see the structure here, this is the phenyl. For the phenyl in the first position, 3 methyl groups with 1 nitrogen. So it is trimethylazaninum. In the fourth position, 1, 2, 3, 4. 4 carbon atoms are there. So it is butyl. So this butyl in the third position, the phenyl group is there. See here 6-membered ring. For this phenyl in the fourth position, the ethyl group is attached. 1, 2. Two carbon atoms means ethyl. See here, phenyl, trimethyl, azanium, butyl. Four carbon atoms means butyl is attached to the fourth position of the phenyl group, and at the third position of the butane, the phenyl and 4 ethyl group is attached. Next to cholesterol structure. If you see the structure of the cholesterol here this is the amino group. For this amino group 1, 2, 2 carbon atoms means ethyl, and here another amino group. So ethyl amino group is attached. To this ethyl amino group, another ethyl amino group is attached, and to this here another ethyl amino, and for this ethyl amino, another ethyl amino group is attached. See here, for this amino group, here ethyl amino, ethyl amino, ethyl amino, and ethyl amino groups are attached to each other. Next, inhibition of LDL oxidation. LDL means low density lipoprotein. The drug is probucol. Drug name is probucol. So this is the structure of the probucol. See here, two phenyl structures are there. Two phenyl structures, and for the two phenyl structures, here two of the sulfur atoms are attached. So these two sulfur atoms are attached to the carbon atom. So this carbon atom is attached to the two methyl groups. So here in the phenyl structures, in the third and in the fifth position, here in the second and the sixth position, that the butyl, 3 carbon atoms, and here 1 carbon atom. So it is butyl. Here butyl is attached here. So two phenyls in the third and fifth position. Here in second and sixth position, the butyl groups are attached, and here two sulfur atoms with carbon. Here two methyl groups are attached. Next, lipolysis are triglyceride synthesis inhibitor. In this example is nicotinic acid. If you see here the structure of the nicotinic acid, this is the pyridine. For the pyridine in the third position, the carboxylic group is attached. The carboxylic acid is attached. See here, pyridine. The 6-membered ring with 1 nitrogen is the pyridine, and here in the third position, carboxylic acid is attached. Next, miscellaneous drugs. First one is ezetimibe, and next one is dextrothyroxine. Next, beta citosterol. Let's see, first one is ezetimibe. If you see the structure, this is the azatidine. For this azatidine, in the second position, oxygen is there, and here in the first position, 4-fluorophenyl. In the fourth position, 4-hydroxyphenyl. Here in the third position, 1, 2, 3. 3 carbon atoms means propane. In third position, hydroxyl group is there. So 3-hydroxypropane. In the third position of the propane, the 4-fluorophenyl is attached. So this is the azatidine structure. In the second position, oxygen. In the first position, 4-fluorophenyl. In the fourth position, 4-hydroxyphenyl. And here in the third position, 3-hydroxypropane. For this 3-hydroxypropane, at the third position, 4-fluorophenyl is attached. Next one is dextrothyroxine. So this is the structure of the dextrothyroxine. You see here 1, 2, 3. 3 carbon atoms at the first position, carboxylic acid is there. So it is propionic acid. In the second position, amino group is there. In the third position of the propionic acid, here In third position, fifth position, iodine group is there, 2 iodine. So di 3,5 diiodo phenyl, and at the fourth position of the 3,5 diiodo phenyl, here 3,5 diiodo 4-hydroxy phenoxy group is attached. See here propionic acid, in second position amino, and here in the third position of the propionic acid 3,5 diiodo phenyl, at the fourth position 4-hydroxy 3,5 diiodo phenoxy group is attached. Next, beta citosterol. Beta citosterol. So this is the structure of the beta citosterol. If you see the structure here, 3 6-member ring is there. That is if you see the structure, this is the 3 6-member ring is phenanthrin, and this is the 5-member ring is cyclopentane. So phenanthrin, cyclopentane. In the 14th position, hydroxyl group is attached. Here in the 9th and the 17th position, 2 methyl groups are attached. Here 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms means heptane. For this heptane in the 6th position methyl, and here in the 5th position ethyl group is attached. See here 2 carbon atoms means ethyl. Phenanthrin, cyclopentane. In 14th position hydroxyl. In 9th and 17th position 2 methyl groups. Here 7 carbon atoms means heptane. In 6th position methyl, and in 5th position ethyl group is attached. Next new drug is Patavastane. So this is the structure here. If you see here 1, 2, 3, 4, 5, 6, 7. So 7 member is the heptane, and here carboxylic acid is there. So it is heptanoic acid. In third and fifth position, 2 hydroxyl groups are there. So 3,5 dihydroxy heptanoic acid. In the 7th position of the heptanoic acid, here quinoline structure is attached. In the 7th position of the heptanoic acid, quinoline is attached. So for this quinoline in the second position, 1, 2, 3, 3 carbon atoms is in the cyclic form. So cyclopropane, and in the fourth position 4-fluorophenyl is attached. See here 1, 2, 3, 4, 5, 6, 7. Heptanoic acid 3,5 dihydroxy, and in the 7th position the quinoline structure is attached. Here in the 4th position 4-fluorophenyl is attached. In the second position cyclopropane is attached. So this is the classification of the drugs which comes under anti-hyperlipidemic agents.